Let's do one of these homework assignments. We have a problem where you have to find the solid, the volume of a given solid. It's under a plane and above a region, so we need to figure out what the region is first. So let's graph these two functions. I think it'd be easier if I had y by itself. So the first one is a line, y equals 1 minus x. The other one looks like it's a parabola that's turned upside down and shifted up 1 unit. So it'd be good for us to figure out where they intersect. So here's the 1 unit, and there's a parabola. Now this is the slope of -1 that's shifted up 1 unit, and it's probably going to cross here at +1. So we have a small little bit of area here. Okay. And so this is going to be helpful for us because it'll help us find the limits of integration. Now, at this point, it doesn't look like it matters much what we integrate with respect to first, but since we already have y's solved for, maybe we'll integrate with respect to y first, and that would entail drawing a line parallel to the y-axis. And so your limits of integration will go with y first. And we're going to enter the region at this line. Y is equal to 1 minus x. And then we'll be inside of the region. We're going to exit the region at this parabola, 1 minus x squared. And then now your x limits are constants. And that's going to go from 0 to 1. Alright, so that is your region, and this will help us set up our integral. So then our integral will become, I need to solve for z here, by the way. So z is equal to 9 minus x plus 2y is going to be your z. And so that's what we're going to put in here. 9 minus x plus 2y is your integrand. That's your function surface up on top. We decided we're going to integrate with respect to y first, and the y limits are going to be 1 minus x to 1 minus x squared. And then we will integrate with respect to x as our outer integral with constant limits 0 to 1. Alright, let's proceed to do this integral with respect to y. 9 is a constant, x is also a constant, and then now you integrate the y, so that's y squared over 2, and then there's a 2 there, so that would just cancel. We just have y squared. And now we have to evaluate this when y is equal to 1 minus x at the lower limit, 1 minus x squared at the upper limit. So let's go ahead and calculate that. Got 9, 1 minus x squared minus x times 1 minus x squared plus 1 minus x squared squared. So that's the first part, upper limit minus the lower limit. 9 times 1 minus x minus x times 1 minus x plus 1 minus x quantity squared. So I'm going to painstakingly go through this, simplify, and then integrate with respect to x. Alright, what do we have here? We have 9 minus 9x squared minus x, and then the negative distributes, x cubed. Foil this out, 1 minus 2x squared plus x to the 4th. So that's the first part. And then we have a big negative sign here. Let's see if we can just distribute as we go along. It'll be 9, a negative, and a negative is a positive. 9x. Negative, negative is a positive. This would just be x. Now there's a negative, and a negative. So that's going to be a negative x squared being distributed. Now this is going to be FOILed out again. We have 1 negative. The middle term is minus 2x. So a negative and a negative is a positive. And then the last term is positive x squared with a negative. So it's negative x squared. Okay, let's collect all the terms. There's only one x to the fourth. I see 1 x cubed. And there's an x squared. There's another x squared. There's another x squared. And there's another x squared. So we have negative 9, minus 11, minus 12, minus 13, minus 13x squared. Alright, how many x's do we have? We have 1, 2, 3, 4 x's. So that's a negative x. Plus 9, so that's a positive 8, plus 1, positive 9, plus 2, positive 11. And then we have constants left. So it looks like positive 9, negative 9, positive 1, negative 1, and that accounts for everything. So that's just 0. Okay, we have the inner integral. Now we're going to integrate that, what we found, x to the fourth. This is a 4, plus x cubed minus 13 x squared plus 11x with respect to x going from 0 to 1. So this would be x to the fifth divided by 5 plus x to the fourth divided by 4 plus 13x to the third divided by 3 plus 11x squared divided by 2 going from 0 to 1. Now the 0 is going to go away, so this is all just 1. So we have 1/5 plus 1/4 minus 13 over 3 plus 11 over 2. Oh boy. Common denominators. 20. I got 60, I think. Let's do it. So well, why don't I just pull out my calculator? So we got 1/5 plus 1/4 minus 13 divided by 3 plus 11 over 2. I think we can make that into a fraction. 97 over 60. I guess it's also important to figure out what the decimal approximation is. 1.616. Okay, so there we go. I did graph this in in CalcPlot 3D, and for this I had to adjust the window. So I can make sure that I'm including everything that's needed, because the plane goes up really high, and then this little region here is quite small. So this is the plane being drawn out right now. So this is the plane, and now I'm going to do a region below it with the same plane, and I can ask it to calculate some Riemann sums. I can show the Riemann prisms, and with a 48 by 48 partition I got 1.3, so I think this thing only goes as far as 50 partition, and got 1.35. I don't know how close that is to 1.6. I guess it's fairly close, you could say. But that is our solution. Alright, and this is the graph that's associated with it. Okay, I hope that helps.